Alright, hello guys. We're going to catch our cookie monster, and to do so we're going to have to make sure that our kitchen is at the right temperature. And the way we're going to do that is through analog sensors, analog devices. So in this tutorial, what you're going to need is your Raspberry Pi hooked up and a way to connect the Raspberry Pi to your breadboard. So this could be jumper cables straight off of the header, or it can be through a cobbler like what I have here. You're going to need your breadboard. You're going to need an analog digital converter. The Raspberry Pi can't take in analog inputs by itself. It needs a way to convert analog signals into a digital signal that it can then understand, and that's what this chip does. This is an MCP3008. Other analog digital converters such as the MCP3004 will also work following along in this tutorial. You're going to need a 10,000 kilo ohm resistor, a light sensor. You don't need it, but I have one here so that we can show how that works. And a temperature sensor, of course, is key to our project, and the temperature sensor I have here is a TMP36. I have the data sheets for the two sensors up here, and you're going to need these data sheets if you want to follow along and know what's happening. So you're going to have to download that as well. So the first thing we're going to do is wire this system all up, and I'll see you after that's all wired up because it'll take a while, and I'll explain to you what the wiring is then. So I'll see you then. So there we have it all wired up, and as you can see it looks a little bit messy. So I wrote out a diagram for what it is that I actually have wired up here. You can see that. Just move the camera down. You can see that right there. So what it is we're doing here is orienting the chip. There's a little notch at the top of the chip and a circle which I represent here, and this is how you start counting the pins. Over here you can see what that means. So we see the notch here on the 3008 or the 3004, channels 0, 1, 2, 3, 4, 5, 6, 7, and then we start counting up around the bottom and wrap up back to the top 9, 10, 11, 12, all the way 16. The MCP3004 only has 14 pins, so it's a little bit different in the wiring, but same concept applies. What you're going to want to do is you're going to want to connect VDD to 3.3 volt, VREF to 3.3 volt, A ground to ground, CLK to SCLK, D out to MISO, D in to MOSI, CS SHDN to CEO, DGND to ground. Now, on the MCP3004, on the left of the MCP3004, you have the D ground, which you need to connect to ground, and you have two no connects, and then you have your 4 channels here. On the left side of the 3008 here, I have my light sensor, which is just a photoresistor, and that is connected to ground, and in parallel to it is my 10,000 ohm resistor connected to VDD. You can see that in the back here. Here is the TMP36. The middle pin is our communication pin, and then depending on how you look at it, the data sheet here shows you exactly how it's wired, but if you're looking at it from above with the rounded side facing you, the pin on the left, so that would be this one farthest to the left here, is connected to ground, and the one on the right is connected to VDD. So that's how you wire this all up, and now you can start measuring light and temperature. Now, Pi B Plus has this layout. Pi B, which only has 26 pins, also has each of those. So don't worry whether or not you're following on the B Plus or the B. That's why I didn't show like a schematic of the Pi, because it depends on which Pi you're using. But we have the different layouts for the headers pins, so just follow your respective Pi's layout and you should be able to get this wired up.